The Gas Meter, Episode 2 of the Gas Service Animated Series. Before gas reaches a single burner, the company has to answer one question. How much did you use? The meter is where the utility's gas becomes the customer's gas, the point of delivery, and it is, quite literally, the cash register of the system. It has to count volume in cubic feet at a gentle delivery pressure of only a quarter psi or so, and stay accurate for years. But gas is invisible, so how do you count it? You trap it, one fixed volume at a time. The residential answer is the diaphragm meter, a positive displacement machine. Inside are flexible chambers of known volume. We're showing 2 here, though a real meter cycles 4. As one chamber fills from the inlet, its partner empties to the outlet. Then internal valves swap their jobs over and over, like lungs breathing in counterphase. Nothing is estimated. Every cycle traps and releases the same fixed volume, so counting cycles counts cubic feet. That's what separates it from a turbine meter, which only infers volume from how fast the gas spins it. Each fill and empty stroke has to become a number. Sliding valves on top of the chambers route the gas, always filling one side while the other drains. The strokes push a linkage that turns a crank, converting back and forth motion into smooth rotation. From there, a gear train counts the turns down, and the final shaft drives the index dials on the front of the meter. Strokes become turns, turns become cubic feet. The index is a row of clock-style dials, each geared 10 to 1. And notice the arrows. Adjacent dials turn in opposite directions, so read the numbers, not the habit. The rule is simple. Read each hand as the lower number it has passed, working left to right. Now the trap. The third hand looks like it's sitting right on the 3. Whenever a hand sits on a number, check the dial to its right. This one still reads 9, so it hasn't finished its trip past 0, and the third dial is still a 2. The reading 4, 7, 2, 9, 472,900 cubic feet. Now the units. The utility bills in hundreds of cubic feet, CCF, and thousands, MCF, which for natural gas is about a decatherm of energy. Your usage is simply this month's index minus last month's. 4729 minus 4682 is 47. 4,700 cubic feet, or 47 CCF. To connect volume to energy, natural gas delivers roughly 1,000 B2 per cubic foot. In approximation, since the exact heating value varies, and the utility corrects for it. And keep one thing straight, the bill always comes from the index dials. The test dial is for testing, never for billing. To find out how much gas the appliances are actually burning, you clock the meter using its test dial, a small dial marked in cubic feet per revolution, commonly 1/2, 1, 2, or 5. With the load running, time at least 1 full revolution. Then the arithmetic. 3,600 times the dial size divided by the seconds gives cubic feet per hour. Here, a 2-foot dial takes 36 seconds. That's 200 cubic feet per hour, and at roughly 1,000 B2 per cubic foot, about 200,000 B2 per hour of connected load. NFPA 54's tables give the exact rates and the pressure corrections. At the meter set, the tech works a checklist. Confirm the meter is actually in service and hasn't been bypassed or tampered with. With a burner running, the test hand should move. Check the location, ventilated, readily accessible, protected from damage and from temperature extremes, and supported without strain, with no heavy corrosion on the set. A meter that won't register under load is defective. That's a shut-off and report situation. The exact steps, spacings, and remedies come from NFPA 54, the AHJ, and your company's procedures. The diaphragm meter in one breath. Chambers trap a fixed volume, a crank counts the strokes, and the index adds them up in cubic feet. Read each dial to the lower number and let the dial to the right settle the ties. Clocking 3,600 times the test dial size divided by the seconds gives cubic feet per hour, and the bill always comes from the index, never the test dial. Next episode, venting and draft. where the flue gases go and why.